Hey everyone, hope you liked my video last week where we went through and scraped conferences from each year in baseball reference of college baseball teams from 2013 to 2019. This week we're going to be scraping within those conferences and getting data of every team from each conference from 2013 to 2019. And as you can see, there's already code here, which is essentially from last week's video in terms of scraping those years to get those years and those URLs. But there is something different. Instead of the dplyr package, we install or call the tidyverse package. Tidyverse is a significantly useful package in R. It has so many capabilities that it can do. Packages like per, dplyr, ggplot, so on and so forth. Definitely, search it up on Google, look it up. A very useful package. So, anyways, let's get started here. As you can see from last week, we'll just do the same thing. We're selecting the 6 years that's available. We're creating a list of URLs that correspond with those years. We're going to create another list of URL ID. I'm going to say list. And then again, years 2013 J equals 1. We'll say a for loop in J in sequence along URLs. Squiggly bracket. URL ID J for the first element in J equals URLs J read HTML and then another piping operator HTML nodes. And this is where we'll do an XPath because we're getting the hyperlinks from each row in the data table, which I will show shortly. So where I get those either XPath or CSS comments, where you see, you may see like a comment or leak batting or all leak batting, I can show you through Google Chrome. There's a function called Selector Gadget, and you can download it from the Chrome store. It's free to use, and you'll click on it, and you can see, let's say you want to pull a certain row, if you will. You can say, oh, I can pull left, and it'll highlight what you're pulling from, as well as, if you want to click out of it. So it's league batting clone left, so that means it only takes the teams in that league by league batting table. You can clear, or if you want to pull the header, you can just pull a header H1, and then this is where you can get the XPath, and the XPath is /H1. And then HTML attribute, and this attribute in terms of hyperlink is href, which is a hyperlink reference. We'll pipe it again, and this time we want to write it as a data frame, and I'll show you why shortly when we look at the data frame. And then you say URL ID J dot year equals years, and then J equals J plus 1, as well as years equal years plus 1. Then we'll run this. Give it a second or two. It ran. And then we can view our list. Those are the URLs, and then this is a URL ID that pulled each hyperlink reference from the data table. So then, to continue, in order to scrape that data from those URLs, we'll do an LD apply, and then we'll say the URL ID, and we want a data frame out of that. So then it will put all the data frames in it. So each ID corresponds with a specific conference in a specific year. And then we want to continue by adding the entire data frame, or adding the correct URL. So we'll do URLs ID.URL, or dot, $ to reference a new column. And we'll do a paste 0. So we'll run that. And you can see all the URLs are correctly aligned with the league ID inside of it. To continue, now we want to correctly identify the conference attached to each URL ID. So how we do that is another for loop, and we'll do for I in 1 to number of row URL IDs, and we'll say conf. We'll designate this as conf, short for conference, and we'll do read HTML. This time we'll put URL IDs URL I to assign each row of the URL, and we'll add the piping operator. And then HTML nodes to reference the nodes. And as mentioned, this is where you get the exact conference. So it'll be metaspan plus span. So you can just copy and paste from Selector Gadget once you do have that. And another piping operator, and you want the text from that, which is the conference. And then after that, you want to put that in a new column called conference of I, so it assigns the correct conference to each row. And you'll run this, and it may take a little while because again it's going through multiple iterations. Copy and paste the next line of code because it's going to take a lengthy process, but I will describe that code in detail with you. So we're going to create another list. Essentially, we're going to go through each row of the URL IDs, and we're going to read HTML, do another XPath, because baseball reference, when there's more than one data table on a page, each data table after the first data table is under a comment. Therefore, we need to extract the comment, collapse the comment, and then read the data table that you want to read, in this case batting. So how you do that is essentially read HTML, HTML nodes, XPath comment, HTML text, paste, collapse to get rid of the comment. Then we essentially do what we did if it was the first data table. We do read HTML, this time HTML node to extract the specific node, which is league batting, and then create a table. Then we're going to properly assign the year to each year, and then properly assign the conference to each conference. Now the last part, sys.sleep, is a system sleep where essentially it kind of halts the code running. That way, you know, your code doesn't time out from too much time. So we run that code. Now that the data scraping is done, well, of course we'll do another ldeploy. So in the deployer package, we'll do a list apply essentially, and we'll say conf table, and we'll convert it to a data frame. So enter, and you can see it pulls up. We have 34 variables. You'll see why. So as going through the data, you can see, you know, there's some NAs, and when we scrape the data, sometimes it pulls up in certain divisions. Now there's a quick way you can automatically impute those NAs with the proper column. So let me show you how to do that real quick. NCAA comps, that's what we named the data frame. And we'll do NCAA comps again to indicate what data frame we're pulling from. Piping it to indicate. Now we're going to mutate, and a mutate essentially means we're going to change a certain column, in this case team. So we're going to do a coalesce, and coalesce is kind of like a SQL function where you takes NA values in a certain column and replaces them with whatever values you assign from other columns. So let me show you how to do that real quick. So team coastal division, let's see, it pops up, south division, red Rolf division, western division, and lastly southern division. So what this coalesce function is doing is we know that if NA is located in the team column, it first looks in the coastal division to see if there's any data there. And if there is, it will impute those values from the coastal division into team, so on and so forth. So then if there's no values in coastal division, it'll go to the next one, and so on and so forth. So first let me fix that to mutate, and we'll run this. Go back into NCAA comps, and you can see those values are imputed. And another way to check if there are still NA values, easy way to do so is you do sum is.NA NCAA comps, what column we're referring to, just team. And we'll control enter that, and you can see there are no NA values. That we want to remove those columns and the affiliation column. So quick way to do that, NCAA comps equals NCAA comps brackets, put the comma here to refer to the columns that we want, and we do a combine element, -2, and then -30 to -34, which means the last 5 columns and the second column, which is affiliation. So I'll run that. Dropped to 28 variables. And again, still all there. Years, conferences, really cool stuff. Going on, now again, we want divisions. We want to separate between Division 1 and Division 2. So from last video, we'll again call divisions by doing a read CSV. And in my files, it's called divisions.csv. And we'll run that. Now we want to merge/join those conferences together in a proper way. But if you can see on NCAA comps, it's considered as conference, whereas in divisions, it's considered league. So a quick way to change the names is to do col names, and we'll say DataFrame divisions. And since it's the first column, we can put it in brackets by referring to the first column. Then we say conference. And we hit that. Now list it as conference. NCAA conf data by creating a new data frame. Merge. Say X equals NCAA, Y equals divisions. Then this is where we'll do by. We'll do a combine element because we're doing more than one combination to, just in case for those schools or programs that went from D2 to D1, so on and so forth. So we're going to do a by conference and year. Then, just in case if it doesn't get all conference data, you have to say all X equals true, so that way no data is lost. Run that and view it. Again, Division 1, and again we can go into another row and say sum is.NA NCAA conf data and refer to division. We can run that and see that there are no divisions available. So head NCAA conf data, piping operator, select, select statement, and we want to select OPS. We'll say team, conference, year, OPS, and we'll say runs per game. Another piping operator, and we want to sort it by range descending OPS. And we'll run this, and we can see the first 6 observations, only one of those 6 teams is Division 1, and it was New Mexico State's year last year where they had a team OPS of over 1,000 and they scored 11.09 runs per game. That's a heck of a season. Feel free to look more into that, but man, that is one incredible season. And you can filter in more, so you can say select team, conference, year, OPS, runs per game, and we'll say division, and then we'll say filter division equals 1, and then add the piping operator, and we'll see what Division 1 programs had the highest. So outside of New Mexico State, it was the Air Force Academy in 2017 with a 971 team OPS. Arizona in the Pac-12 in this previous season, 966 OPS. And we see North Carolina Greensboro in 2016, 963 OPS. The defending national champions Vanderbilt, the 943 OPS, and then University of New Mexico in 2013 with a 927 OPS. Now, thanks so much for watching. I hope you learned a little bit more about scraping hyperlinks and getting more baseball reference data, and hopefully you can play around with it and see what if there's any useful data information. But feel free to like and subscribe. Next week will be more videos, and hopefully, it's a good learning process for you. Thanks for watching.